Yeah, a very good morning to everyone. I hope I am audible. Ritu just confirm me this.
Yes, ma'am, you're okay.
Yeah, thank you very much. At the outset, I take this opportunity to extend a very warm welcome to all the participants across India on the very important topic of faculty development program, which is on data sciences. Before I speak about data sciences, I think I'll take just 2 minutes to talk about Indira Gandhi Delhi Technical University for Women. Indira Gandhi Delhi Technical University for Women is the first women government technical university established in the year 2013 to promote women education, women empowerment, and women enlightenment. The devouring strides of IGT2W since its inception has been exemplary, culminating in transforming itself into an icon of women empowerment. It is a matter of stupendous pride for all the faculty members, including myself, to be a vibrant part of this illustrious edifice of teaching and learning. The university, as of now, it is offering various undergraduate, postgraduate, and PhD programs. We have almost 8 undergraduate programs. We always make an attempt to offer courses in the advanced and emerging areas of technology to ensure that it meets the contemporary needs of the industry. So the undergraduate programs like undergraduate course in AI and data sciences, computer science and engineering, information technology, electronics and communication engineering with specialization in AI, and so on and so forth. This university is equipped with the state-of-the-art infrastructures, and our university has been a placement and job utopia for many of the students. On one side, during these unprecedented times of COVID, when there was an extreme problem of jobs, the other hand, IGT2W was making its presence felt by having its captions appearing in all newspapers for fetching the best of the placement and the best of the internship for the students, as good as around 60 lakhs of package to the students and 2 months internship with internship offer of 1.6 lakhs per month from companies like Uber, etc. So our students are doing excellent and exceedingly good work. Coming down to IGT2W, its Center of Excellence, we are in the process of setting up a Center of Excellence in Artificial Intelligence, Center of Excellence in Mechatronics, and our incubation center is having a whooping funding of around 6 crores to set up Nidhi, which is the Center for Innovations in Entrepreneurship. So it is only for the information of the esteemed participants across India. If anyone is interested in these areas, whether incubation, entrepreneurship, or the joining hands in Center of Excellence in AI and data sciences, or joining hands in the area of Center of Excellence in Mechatronics, will be more than happy. Now, I'll switch over to the topic for the day, which is for data sciences and insight into data sciences, concepts and methodology. I think data sciences is something which is making its presence felt across everywhere, and irrespective of whether we are in any field, AI, deep learning, and data sciences, they have become as if the part of our everyday life. It all started with the fourth industrial revolution, which was first introduced by World Economic Forum. Perhaps it was October 10th, 2016, when the forum announced the opening of Center of Fourth Industrial Revolution in San Francisco. Since then, we see breakthroughs in all emerging technologies, and the transition to data sciences, AI, and deep learning is literally undeniable and accelerating, disrupting all the government and business models, meaning thereby it has really transformed how we used to collect data, compile data, collate data, and used to interpret data. Gone are the days when it used to be a manual process. Today, these new models of data sciences, AI, using AI and deep learning has redefined the way organizations create, capture, and deliver values. They are challenging the ways systems used to operate in the past, bringing new mindset and new practices to the industry. Hence, it is very, very pertinent for all of us to be a part of this data sciences journey, irrespective of in whichever field we work. Can I share my slides? Please give me the option of sharing my content and slides.
Please fire. Get a present.
I hope my slides are visible.
Yes, ma'am.
Yeah.
Yeah,
So
yes, ma'am.
that is today being the first lecture and the first one right in the morning. So let's look at into the insight of some of the data sciences, concepts and methodology. If I talk about data sciences, what is data sciences? It is nothing but a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Now, the structured and unstructured data, normally in our conventional methods, we are always working with our unstructured structured data. But in the case of data sciences, it is interesting to note the most of the data which is being generated by the enterprises, by the organizations is our unstructured data. So it all deals with the unstructured data. And it is important that we are able to work with the unstructured data. And data sciences is the set of tools to make sense out the business problems using disparate data sets. When I talk of disparate data sets, because it is unstructured data, the examples of unstructured data could be your text, your social media, the images, the surveillance data, the tweet data, social media data. They are all the examples of unstructured data. So data sciences, basically, it is a set of tools to make sense out the business problems using this disparate data sets. Now, data sciences is an amalgamation of your data, which is data consulting, data research, data technology, and which is statistical computing, statistical modeling, visualization, scientific methods, and so on and so forth. It means it is using primarily a set of tools and techniques to do interpretation out of the data. Usually there is always a confusion. Where does the data sciences stand? Is it AI? Is it part of our machine learning? Is it a part of deep learning? And so on and so forth. But if you see it now, this particular slide is throwing some light. AI, everything, AI is the superstructure which is hosting now machine learning. Machine learning is a subset of AI. And if you see somewhere deep learning is further a subset of machine learning. And data sciences is a field which is using deep learning, machine learning, and artificial intelligence. And besides that, it is also using extreme statistical processes, which could be dealing with statistics, right from hidden Markov models to any statistics as simple as mean, standard deviation, variance, randomness, skewness, and so on and so forth. So AI is something which encompasses machine learning, deep learning, and data sciences is the science of data, which is using the AI techniques, machine learning techniques, deep learning techniques, statistical techniques. Just give me a second, please. Yes. Now, type of data science models. If we talk of data science, the various components of data science would be, first and foremost, data analysis. We need to analyze the data. And after data analysis, which itself is a big area, I'm just giving an introduction to these things. So data science will involve data analysis, and data analysis will have whole lot of algorithms, processes. How do we analyze the data? Whether it is a structured data or it is a unstructured data. Are we dealing with the ordinal data or are we dealing with the nominal data? Ordinal data is the data which deals with where a ranking is important. For example, if I'm looking at the educational qualification of the candidates, so whether the candidate is BTech, MTech, PhD, so PhD person will have a rank higher than MTech or BTech. So that data will be called as a ordinal data. But when I talk of a nominal data could be the sex of a person, can it be male or a female? The pin codes of a country, could it be any pin code? The name of the countries, and so on and so forth. It is irrespective of the ranking. There is no ranking involved. That will be called as a nominal data. So further, when I go into the data analysis part of it, we need to look in very, very categorically that whether the data, it is having any missing values, whether the data is a noisy data. Noisy data would again mean that it is having some spurious values, missing values, invalid values, irrelevant values, and so on and so forth. And then we go for techniques. How do we plug in this gap? How do we take care of the missing values? Could it be looking into all the values and seeing what should be by missing value? Could it be that in case if it is comprising of big data, which is having millions of records, by removing one or two records, if it is not making any difference to me, I can simply remove those tuples. That can also be done. Or draw some pattern analysis techniques by looking at the data and seeing what kind of a pattern it is representing. Does it fall into the female category or a male category? A simple instance that the sex of a person is missing and it is having features around 200 features. But one feature, as far as sex of a person is concerned, is missing. So what can be done is some kind of analysis can be done on rest of the features. Look into it that what prediction does it give? Does it give that this particular data where the sex of a person is missing, is it a male or a female? And then plugging in that. So that will be the part of the data sciences of data analysis. This is huge. And then looking at into the data analysis, we go into the clustering techniques. Now, clustering techniques would be that how do I make the most appropriate clusters of the data? For example, if I'm dealing with the cars, now these cars could be small car, big car, or these could be very expensive, branded, state-of-the-art cars, let's say Ferrari and others, Ferrari, BMW, Mercedes, others. Now, how we have a data which is containing billions of records. Whenever we talk of a data, I hope everyone is clear. What do you mean by a big data? Big data is a data which is in kilobytes, megabytes, gigabytes, terabytes. What is that big data? Usually the definition of the big data, it comes from terabytes to petabytes. Any data which is of terabytes or petabytes and going up to exabytes, zettabyte and yottabytes are the big data. So whenever we are dealing with big data where we have millions and millions of records, for instance, I have data of the cars which is having millions of records, and it has also around 100 parameters or the features. Features could be make of the car, size of the car, length of the car, width of the car, or it could be the color of the car, the usage of the car, the mileage of the car, technology being used, 2-stroke, 4-stroke, and so on and so forth. That could have n number of features into it. Now we want to appropriately club them into clusters which are our expensive cars, middle range cars, and the least expensive cars. So we can deploy a technique which is called as a clustering technique, which will be unsupervised technique. Similarly, if I want to compare two models, I can also deploy the technique of regression, a regression technique which will compare two or more features, and it can use the technique of regression. I can do a simple classification. Classification, if I have to do a simplest classification, there are a number of images which are available to us. Some images are of sunflowers, some images are of roses. Now, out of these images, which images of rose and which images of sunflower, that can be a simple classification problem which will be under the supervised learning. Now, feature selection. Feature selection is that whenever we are dealing with the data, as I gave an example, let's say my data compasses of 200 features. Question number one is every feature very important to me, or can I remove some of the features? So feature selection is a criteria which will help us to look into the features very deeply, very insightfully, and then select which features are very valuable and useful, and which are the features I can drop. What is the purpose of dropping the features? See, everything comes with a cost. If I'm dealing with 200 features and I feel out of these 200 features, there are 50 odd features which are not making any difference into the classification, into the clustering, into the regression, meaning thereby it is not passing any pertinent information. By dropping those 50 features, I'm not losing the intensity or the clarity on the data. So those features can be dropped, and with that, what I will achieve is the efficacy and efficiency. Text mining. Text mining is, I believe, is the very, very important technique which we are talking. Normally, there is a confusion between text mining and data exploration. What is text mining and what is data exploration? My subsequent slides will talk about that. And then time series forecasting. What is this time series forecasting which we use in data sciences? And today, I must say, everything which is very, very complicated, complex, has been taken over by deep learning. Deep learning is so popular now, you must have seen when you use Facebook is automatically tagging your friends. Automatically, it is showing you the reflection. Do you know and would you like to tag? Even your own image, your friend's image, your friends or friend's image, if it is upside down, whether that image was taken 10 years back, was he wearing a hat? Was it an image with a beard or without beard, mustaches or without mustaches? It is able to suspect, it is able to give you that, yes, seems to be the same person. This all is possible through deep learning, through object detection, through object visualization and object tracking. So deep learning has gone so powerful, it has literally redefined the way we used to work and behave, and we used to deploy the techniques. If you ask me honestly, the techniques like regression, logical regression, binary regression, a simple classification, clustering, all have been empowered. They have been taken over by deep learning. Now, if I look at a regression, what is a regression? Regression is nothing but it is a statistical model which is determining the strength and character of the relationship between dependent variables and series of other variables. So, for example, if I talked about a car make, car size, car type, whether it is Nissan, whether it is Toyota, whether it is any other brand. So that is the car type. Well, how big is its fuel, whether it is a hybrid vehicle, whether it is a electric vehicle, that could be also the type. Then whether it is an autonomous vehicle, again, autonomous vehicle, autonomous level 0, 1, 2, or 3, they could be another features. So if I want to draw a relationship, all these features will be called as my independent features, and I want to find it out a feature or a variable which is my dependent variable, that given all these features, what it would be costing depending upon the age. If I'm looking at second-hand vehicles, the age of the vehicle, it has lived its life for 10 years, 15 years, 5 years. So all these parameters will become my independent variable, and it will try to compute my dependent variable, let's say the cost. Then I can use a simple function as regression function, which will be given by y is equal to a plus bx plus residual function, which will be just an error, because whenever we are computing, there is always a cost function. An error will come automatically with it. And you understand, if I look at y is equal to a plus bx, it is nothing but it is a straight line. It is the equation of a straight line. And how is an equation of a straight line? Because a will signify my intercept and b will signify my slope. So it will show the relation between my dependent variable and independent variable. And think of the use cases of regression. It could be my predictive analysis. Predictive analysis could be, today, my temperature is so and so, humidity is so and so, and precipitation level is so and so in the weather. Let me predict how the weather would be tomorrow and in the coming days. Or it could be useful in the supporting decisions. It is in the operation efficiency, that my inventory in my supply chain management system in different stores is X, Y, and Z. Looking into the rate of usage of this inventory in my supply chain, it can predict what would be the requirement of different materials, which is fast moving item, average moving item, and a slow moving item. The graph on the right hand side is indicating you your independent variables and dependent variable. And there is a line of regression, which is indicating the perfect line, which is showing that how my independent variables and dependent variables are related to each other. So second point, which I spoke even earlier also, is about clustering. And clustering is a technique that involves grouping of the data points. I have different type of the data, and there is no ways and means. I mean, if I'm dealing, let's say, with millions of records, with these millions of records, I need to bring the similar data in a similar clusters. For example, think of a shopping mall where number of persons are going and they are buying various different products, or when they go for a grocery, they are buying. Now, we want to do a detailed analysis as to what are the items they should be placed together on a common deck, so that when a person is moving out, he knows or she knows, along with the bread, butter would be needed, eggs would be needed, and perhaps looking at the trend, looking at the pattern during COVID times, is there something else also which they look for? So by analyzing the trend of all the customers which are visiting the super mall, I have millions of records. I will try to work out the clusters, which is showing the best response of my customers during the given time. And I can predict by looking at these clusters that now my preparation in the super mall should be like this. So on the deck, besides these 4 items, 4 more items should be placed, because that's a trend it is indicating. So the goal of clustering algorithm is to classify each data point into the specific group. It doesn't work that easy way, the way I'm explaining, because the moment you're making clusters, it will have outliers also. There could be outlier which is lying on the boundaries of these clusters. So that, let's say I have 3 clusters, cluster A, cluster B, and cluster C. Now there is some outlier which is lying in cluster B. Ideally, it should have been in a cluster A. Or there is an outlier which is lying in cluster C. Ideally, it should have been in cluster B. Or there could be certain data points which are neither into A nor into B. They are into the open area. So where it should be going? Should it be going into cluster A, cluster B, or cluster C? As you know, we deploy various techniques, for example, Manhattan distance, Euclidean distance, K-mean clustering, and so on and so forth. This itself is a big topic in which we talk about various clustering algorithms. So these algorithms can be applied to work on the data. Now, data points in the similar group will have similar features, while data points in the different groups will have dissimilar features. Now, various different variants of clustering. I can have simply a partitioning clustering. I can simply partition different items into different clusters. It could be density based clustering, depending upon where the maximum density. Let's say if I'm talking of, let's say in USA, and in USA, I would like to figure out where maximum population of Indians are seen. So Indians are spread in USA across, but I would like to see maybe in Silicon Valley, I'll find that the density is far more as compared to maybe in Manhattan, maybe in New York, maybe in Philadelphia, and so on and so forth. So it could be a density-based clustering. Hierarchical clustering could also be there where I deal with the hierarchies. I hope you understand a hierarchy, that in the hierarchical order, I would like to do a clustering, or it could be a fuzzy clustering. Could it be weather prediction? Could it be stock prediction? And so on and so forth can also be categorized into the fuzzy clustering. It's giving you at the bottom left, is giving you an example where I have input of balls, and these balls now I'm going to do a kind of a clustering. Here it is a clustering which has been done into 3 categories, or if you are interpreting it as a classification, so it is giving me 3 classification: white balls, the balls with the diamonds onto it, and the balls which are yellow color balls. Now it has deployed various techniques. You can deploy as easy techniques like regression, base classification, and logical regression. Binary regression, of course, will work with the 2 sets, and so on and so forth. So the clustering algorithms or a K-mean clustering, they can be deployed. Now, association analysis. Association, as the name indicates, association is a technique which checks for dependency of one data item on another data item. So I take one data item, means one feature, and I see how this feature is affecting the performance of the other feature. It tries to find some relationship or association among the variables of data sets. I give a simple example. If I look at the height of a person and the weight of a person, now height and weight, usually it is seen the person having a much bigger height and will have more weight, and then accordingly I calculate the BMI index. I'm talking of just 2. So it could be that I would like to see the association, how does it work? Or if I have to buy a property, so if I look into South Delhi properties are much more expensive as compared to East Delhi or North Delhi. So what are the parameters? How old the property is? How big is the area of the property? Is it lying on the main road? Is it away from the main road? Is it into the interiors? Does it has a view of the garden? Does it has a lake view? And so on and so forth. So looking at these parameters, I will see the costing. So costing will be figured out, and I will see an association. I will try to draw an association. If it is a South Delhi, the costing is higher. If it is a North Delhi, the costing is lower. If it is on the main road, the costing is higher. If it is a commercial property, costing is higher. So we try to do some kind of a association analysis looking at the various features. And there could be even a rule-based association. Let me go to the other slide. This slide may not be very clear. So I take up anomaly detection. Anomaly detection is any process that finds out the outliers of a data set. Now, as I said, whenever we are dealing with the data, definitely, after all, machine is a machine, and a data, number one, it may not be a clean data. It may have inappropriate data. It will have some missing values. It may have some incorrect values. And first and foremost important thing is that the data should be cleaned. We should do a cleaning of the data, which is very, very important. I'm presuming if the data cleaning has been done, and after that we are deploying certain computer algorithms to do the clustering or a classification, but at the same time can come across outliers of a data. So that process to figure out the outlier will be a anomaly detection points. And these anomaly points to unusual network traffic or simply identifying data for cleaning before analysis. So when I say anomaly, so anomaly means what? My data pattern is working and looking at my independent variables, I have computed my dependent variable. Morning times, if I'm moving from North Delhi towards Chanakapuri, morning 9 to 10, there is a VIP moment. Traffic is very high. Hence, my red lights will observe less time as compared to afternoons, or it may observe more time. So this is my normal and it works out fine. But some other time, suppose there is a moment of Honorable Prime Minister. So this model of mine, which I have trained, will not work. It will give me spurious results. So I will consider it to be an unusual network traffic where it may not work. Or I have given an example. So anomaly detection could also be identifying my missing data, spurious data, noisy data, invalid data, illegal data, which is sitting among millions of records. How do I find out that anomaly? Now, anomaly detection use cases could be enhance communication around system behavior, improve root cause analysis, reduce threats to the software ecosystem. These could be the use cases for it. And recommendation engines. I think we all, especially during COVID time, we all have used our recommendation systems. Netflix. Do you know that when you use Netflix, 80% of Netflix is being recommended by your recommendation system based upon your past history, based upon what are your likings, dislikings, based upon what kind of the movies you have seen in the past, what kind of the friends you have, what kind of movies do they see, and based upon that, it is giving you recommendation. And it is also a known fact, most of the time we watch on Netflix, 80% of what is being recommended by the recommendation system of Netflix, and we don't use our own thinking. This is the way our recommendation systems work. Similarly, you must have seen nowadays, it is very, very prominent. When you're typing out something, it shows you the next word. Of course, that is also a kind of the recommendation system because it has seen what kind of the mails do I write, what kind of the words do I use. So it tries to complete that word automatically. So whenever I'm looking into the my maps also, and it will immediately prompt me if I have always stopped at CCDs, if I have always stopped at the fuel stations or the gas stations, if I've always used the toilet facility, it will try to prompt you the toilets which are coming nearby or the gas stations which are coming nearby are the kind of the recommendation systems. When I'm using various apps for purchases, whether I'm going on Nika, whether I'm going on Myntra or any other, it tries to show me what were my purchases in the last, whether I am a computer freak, whether I wear westerns, whether I wear Indo-Western, whether I wear Indian dresses. It tries to immediately prompt me the recommendations. If I'm a big fan of the L'Oreal, definitely next time you will see always it is showing you L'Oreal over any other, maybe Maybelline. So that's a recommendation system, and that's a proven fact. 80% of the human brains are working on the recommendations which are proposed by the system. Type of the recommendation engines, it could use a collaborative filtering, it can use a content-based filtering, personalized video rankers, knowledge-based recommendation systems. I'm sure the coming lectures will be throwing light on all of them. This being introductory, I'm just setting the pace that what all the data science will encompass. Now, deep learning. As I said, if you ask me today, and from today or everything is rotating towards deep learning. Simple classification, simple clustering, simple regression, simple stochastic models, they really do not work. I'm working on intense models. And those models are represented by deep learning. As the name says, deep. Deep means penetration. Penetration how? We have been working on clustering. We have been working on artificial neural networks. A simple artificial neural network will have an input layer, will have a maximum 1 or 2 hidden layers, and then an output layer. Now, input layer is taking your features. With these features, they are being passed to the hidden layer. Now, these hidden layers, They are trying to learn the pattern. They are learning the pattern and accordingly adjusting the weight of the weights which are there with these neurons which are attached, and then find out the output. Output during the classification, let's say the output represented is y, and what I'm getting is y hat. So y minus y hat square is my loss function, and then it will do a back propagation to find out and minimize this loss function in the simplest term. What did I use? I used one input layer, one hidden layer. The moment I talk of a deep means multiple layers. So one of the manifestation of deep learning, I said one of the manifestation, it's not all. Just one manifestation is using multiple hidden layers. You will be astonished how many hidden layers. From one or two hidden layers, which used to be very, very prominent just 10 years back, or I will go back almost 6 to 7 years back, when we used to work on a simple artificial neural networks using one or two or three hidden layers. Today, deep neural networks, they're using as many as 40 hidden layers, 100 hidden layers, and so on and so forth. Meaning what? Meaning it is going down deep to learn the weights, bringing the reasonability so that my classification, my clustering is as good as it was expected. It is learning and learning weights. The features which are given to the input layer, let's say 200 features, they are being passed to the hidden layer 1, hidden layer 2, hidden layer 3, hidden layer 4. And what it is doing, it is trying to converge the network. Converge means reach to the global minima. What do you mean by global minima? Global minima is reducing, minimizing the loss function. Loss function, as I said, if it is represented by y minus y hat square, y is what is I'm expecting the output, y hat is what my system is giving the output, my loss function is y minus y hat square, and I want to minimize this loss function. So for minimizing this loss function, I will train my network to learn and relearn the weights. And training the network will happen through the back propagation. And when I'm doing a back propagation, I'm learning those weights. Learning weights through passing them through 40 to 50 to 60 hidden layers. You can understand the complexity of the deep neural networks. And these deep neural networks, that is the reason you are able to tag your friends, you are able to visualize the objects, you are able to, I hope you have heard of ImageNet. ImageNet is a global competition across the world where every year images are given, and these images are not 100 or 1,000. We are talking of millions of images, and people participate and they propose their models so that how best and how fast these images they can be categorized. And on this, various models have been built up, which is VGGNet, VGG16, VGG32, InceptionNet, ResNet, and Microsoft has participated, Google has participated, Facebook has participated, and there is a very prominent one called as GoogleNet. But now, using these models, you can also see, looking at the traffic of India, and now there are hundreds, thousands of cars going on. You want to come up with the best of the model. What should be my best model? How much should be my traffic control using the red light, using the yellow light? How long that yellow light should be in milliseconds or in seconds? You can use deep learning models. When I'm talking of autonomous vehicles, and that's a reality. Autonomous vehicles are moving in the suburbs of California, transferring refrigerators across using autonomous vehicles and trucks, which are driven by nobody except the system itself. How the system is defining or figuring out the difference between paper lying in front of it, vis-a-vis a rock in front of it, vis-a-vis a car in front of it, vis-a-vis a human being standing in front of the autonomous truck. It cannot. A simple algorithm will fail and it will lead to devastating results, wherein we are claiming autonomous vehicles will save life. Autonomous vehicles will save fatigue, and that's happening on the suburbs of Phoenix. So what it is using is deep learning, networks. It has deployed various sensors which are sensing the data. It is using the pattern recognition techniques. It is using deep neural network techniques, and it is having millions and billions of data. And then those objects are there, those images are there, and it is using convolution neural networks, which I say today, if you ask me, that's also obsolete. If you ask me that the double convolution neural networks, perhaps much bigger, much better object identification algorithms have come in. So they are all using deep neural networks. So it's all about data, whether the data is of images, the data is of sensors, the data is of objects, and so on and so forth. I'm setting a pace for you to know that we need to go inside into these learning models, which are called as deep neural networks, and they work on the behavior of the function, the way our brain works. In our brain, we have millions of neurons which are connected with billions of neurons with trillions of interconnection. So I'm talking of billions of neurons with trillions of interconnection. In the deep neural networks, I don't deal with those many neurons and interconnections, but yes, it is a manifestation of our brain which has billions of neurons connected with trillions of interconnection. So they learn your feature hierarchies, and these models are inspired by information processing. This is the way your deep neural network would look like. Currently, I have shown 3 hidden layers, but you can now do a flexibility and bring up around 50 layers. So you can imagine how complex and complicated it would be. And I think you have to tell me when I need to stop, because I love to be with teachers, participants, and I can go on and on. So once someone has to give me a nod when AICT is starting with their formal inaugural, and then I will be stopping there. Do I have 1 or 2 minutes more with me?
Yes, ma'am. The AICT inaugural is scheduled at 11 o'clock. So we have 2-3 minutes with us, ma'am.
Right, right. So I'll stop after 2-3 minutes. So if you look at this particular example, which is giving you the input layer, which is giving you the hidden layer 2, hidden layer 3, hidden layer 4, and then the output layer. Very, very interesting and fact is, I'm just going a bit into the history of these neural networks. You know, when we used to work almost 2 to 3 decades, we have been working on neural networks. And 3 decades back, we used to work with artificial neural networks with only 2 to 3 hidden layers. And suddenly we found a dip somewhere in 1980s, 1990s. There was a dip in the usage of neural networks because they were not performing. Not performing was because I was using the activation function, which was the sigmoidal activation function. If you people have worked with the sigmoidal activation function, so the derivative of the sigmoidal activation function, and if you see an activation function like sigmoidal, which is a S-shaped, and the derivative of sigmoidal will be between 0 to 0.25, that will be the derivative. So when I used to have an activation function, now these activation functions, they are used for my weights, initialization of the weights. Definitely initialization will be done with hyperparameter optimization. But when I used to deal with these weights, I'm using a sigmoidal activation function. The changes it will make to the weights will be of the tune of 0.25 and so on and so forth, resulting in I could not use multiple hidden layers because of the sigmoidal activation function. Today, suddenly, these deep neural networks have come back after 2 decades or so, somewhere around 2000, 2010 or so. They became once again popular, and they came back with a renewed energy because of numerous other activation functions like ReLU, parametric ReLU, and so on and so forth, which have the capacity of transforming and training the weights of the hidden layer neurons. And these ReLU functions will work like if it is less than 0, the weight will be initialized to 0, or if the weight is greater than 1. So depending upon the value, it will take that particular value. And the derivative of the ReLU functions is much better than the derivative of a sigmoidal. Reasoning thereby, using ReLU functions, I was able to work out on many, many hidden layers. The problem of underfitting, overfitting could be resolved very easily. And also the softmax activation functions have come up in a big way to move the history from simple artificial neural networks to deep neural networks. Maybe during the course, if I have more time, I will take up one complete lecture on to deep neural networks. So this is the way you can see the connections. Look at the amount of the connections. But definitely, when I deal with these many connections, my simple CPU fails. It fails to work with millions of connections, and I have to switch over to GPUs. These GPUs with multiple CUDA cores, and these CUDA cores which are doing a parallel processing and which are doing the learning, which are performing training, even on these CUDA cores, even on these GPUs, when we perform, it takes sometimes, depending upon the data, it takes us as many as 4 days to train the data, 5 days to train the data, and then we test our samples. So that's very, very interesting how the data sciences is migrating from a simple regression, simple classification, clustering, to an artificial neural networks, to the deep neural networks, from convolution neural networks, to the LSTMs, to the bidirectional LSTMs, to the transformers, to the autoencoders, decoders, and then now to the BERT, and then to digital BERT, and so on and so forth. So there is a complete paradigm shift from artificial neural networks to the deep neural networks, and data sciences is being blessed because of these algorithms in place. We are able to deal with the data, we are able to deal the predictions of an enterprise, of an organization. I think I'll stop here because I don't want any of my esteemed participants to miss out on to the AICTE inauguration, which is being done today. And I wish all the very best to all the participants. I hope these sessions will be knowledgeable sessions. You will learn a lot, and after 1 week, you will find there is a big change, and you have a better perception of the about the data sciences. Thank you very much.
Thank you, ma'am. That was an insightful and enriching session. Thank you for sparing your valuable time from your busy schedule. And thank you to all in attendance at the session, and I wish you an enriching and successful sessions ahead. I would now like to request Professor Nidhi for vote of thanks.
Thank you, ma'am. Thanks a lot, ma'am. Yeah, thank you, Ritu. Thank you, ma'am. Thanks a lot for sparing your valuable time and putting light on the various basic foundation aspects, covering right from the foundation to the advanced, whatever is there in the application area. So it's indeed a very good lecture, and I am sure the participants, they have learned a lot, and this actually have set a very good pace for the week to come. And I'm sure during the week they will learn a lot about the data sciences. And I thank ATAL Academy for sponsoring this FDP program on data sciences. This is the foundation elementary level course, and we'll be having advanced level course in the September as well. So I request the participants who have joined over here, they can go for the advanced level as well. And right now we'll just disperse, and I request all the participants to join the ATAL Academy inauguration for the 63 ATAL FDPs that will be hosted for this 26th to 30th July week. The link for joining that session will be shared on the WhatsApp.
Thank you, Nidhi. Thank you, Professor Jasdeep. And I must compliment both of you for taking this initiative of launching the faculty development program. And I'm thankful to the participants for showing their keen interest. And a big thanks to both of you, because to take me out from my administrative responsibilities and putting me onto my technical sessions, which is always lovable, and it is a wonderful experience to be with our own faculty members. Thank you very much.
Thank you. Thank you, ma'am. Thanks a lot. And I would like to take this platform to thank my organizing team as well, because that would not have been possible, without them to organize this FDP. The co-coordinator, Professor Jasdeep Kaur Dhanoa, and my organizing team, Ritu Kandari, who is obviously, managing the entire show. And maybe in the next session, you will see Miss Neha Kapoor. They are dealing with all the participants and all the speakers throughout, last 10-15 days to make this event possible. Thank you. Thank you all. And Yes, ma'am. You want to say something, ma'am?
I think
Yeah, Neha is
we'll
also
join
here.
at 12:15. We will be
Yeah,
joining
we
at
will join
12:15.
at 12:15. And at this session, I request all the participants who have not received the link through, Google group or WhatsApp, I request them to stay a little while over here. A rest can leave. Because Ritu, I received almost 10 to 15 mails since yesterday evening that their stature is approved on the AICT portal, but they have not received any mail or they have not been added to any WhatsApp group. So let us sort that out. Or what these people can do is they can just put their mobile number in the chat box and we'll add them to the WhatsApp group.
And I think they are not here in the session itself. Because
I
if they
have
have not
shared.
received the link,
Whosoever mail I have received, I have shared the, joining links with them. So there is one Pratima, Sunita, Shalini, Sharon, Satish, Ganesha Karna, Anshika, Priya, Alka. I mean, so many faculty members are there who have not received the link. Alka Vinayak is here. Ma'am, you can just share your number over. We have received one number in the chat box. Priya Vij, we have received Dr. Priya Vij. Ritu, just take a look on these numbers and add them manually to the WhatsApp group. Himani Tyagi is also there.
they're saying that it was in the spam. Some of them are saying. So you can, what you can do is you can, along with your phone number, you can send your alternate email ID. Something it is with the organizational email ID, which does not allow you to be a part of Google. So that can be a constraint. Along with your number, please share your alternate email ID. I'll take a look.
Okay. Thank you, Ritu. We'll continue at 12:15 now. And I'll just join at the ATAL inaugural. All of you can also join in. Thank you. Thank you all.
Link is shared with you in the chat box. It is on YouTube.